This video is for Homework and Mastery 1.3, Section 3.4 in your textbook, Performing Operations with Exponents. What we want to look at here is some of the basic rules of exponents. When we look at the product rule for exponents, what we're saying is if the same base is multiplied by each other, we're going to add its exponent. So it doesn't matter if it's a constant or if it's a variable. If it's the exact same, we actually add the exponent. As shown here, x to the a times x to the b is equal to x to the a plus b. I've added the exponents. So if I look at these and I want to multiply and write the product in exponent form, starting off with a, I have x to the fourth times x to the third. Now if you recall what x to the fourth actually means, that means x times x times x times x. And x to the third means x times x times x. I can rewrite that as x to the 4 plus 3, and that gives me x to the 7th, because actually what I have is 7 x's multiplied together. Now whenever we look over here at the y's, remember, if there's no exponent, it's an understood 1. So whenever I go to write this as a single exponent, I have y to the 5th times y to the 1st. So I'll add 5 plus 1 and get y to the 6th. Down here I have 3 to the 5th times 2 to the 4th. The bases are not the same. I have a 3 and I have a 2. So I can't do anything. The rule doesn't apply here. So this would be a simplified version as I could get at this point. Now here I have 3 to the 3rd times 3 to the 5th. Now I can add these exponents and say 3 plus 5 gives me 3 to the 8th. The reason why we're going over this is so that we can actually multiply items that have coefficients, exponents, things of that nature. And I want to look at the rule for multiplying algebraic expressions with exponents. We multiply the numeric coefficients, the numbers out front, and then we use the product rule for exponents. So if you notice here, we have 5a squared times 3a to the 4th. And what we do is we multiply its coefficients, or the numbers out front, 5 times 3, which gives me 15, and then we add the exponents of the a's. A to the 2nd times a to the 4th, 2 plus 4 will give me 6. So let's look at some examples. Here I have 8 a to the 3rd times 2 a to the 6th. And I want to multiply these. Since everything is multiplied, I can rewrite it with commutative and associative properties where I have the coefficients together and the variables a in the same parentheses. This just makes it a little bit easier for me to look at, because now I have 8 times 2, which will give me 16, and a to the 3rd times a to the 6th will give me a to the 9th, because I added their exponents, 3 plus 6. And I put those together and get 16 a to the 9th. Notice, whenever I'm multiplying here, remember I add the exponents. Let's try another example. Here I have 4a to the 4th, 5y to the 3rd, 2a squared. Again, what I'm going to do is I'm going to write it where all my coefficients are together and then all my variables are together. Such as here. I have 4 times 5 times 2, and then I have a to the 4th times y to the 3rd times a squared. Notice I put the a's in red, because those are the only ones that I can combine, because they're the only ones that have the same base. And therefore, those are the only exponents that I can add together in my final answer. Now then, 4 times 5 is 20, times 2 will give me 40. A to the 4th times a squared, 4 plus 2 gives me 6. My y to the 3rd just tags along because it has nothing to combine with. Here are a couple of other examples. I have 6x times negative 3x. Well, if I look at it and multiply my 6 times negative 3 and then my x times x, I will get negative 18 x squared, because remember, 1 and 1. Now look at negative 8x squared times negative 5 y to the 3rd. Again, think of it as negative 8 times negative 5 x squared times y cubed. Negative 8 times negative 5 will give me a positive 40, but remember, the x and the y, they're different bases. I cannot combine their exponents, so they stay separate here. And I have my final answer as 40 x squared y cubed. Now what we want to do is we want to look at terms such as polynomials. Polynomials are expressions that contain terms with only whole number exponents and no variables in the denominator. There are several different types of polynomials. There's a monomial. It just has one term, such as this. There's a binomial that has two terms. This is a good example of binomial. Remember, terms are separated by a plus or minus sign. And then we have trinomials. I have 1, 2, 3 terms. Anything over a trinomial is just called a polynomial, multiple terms. So look at these three and identify it as a monomial, binomial, or trinomial. Well, the first one, I have one term, two terms. So 2, that's going to be a binomial. On part B, I just have one term. So that's a monomial. On part C, I have 1, 2, 3 terms. So that's going to be a trinomial. What we want to look at now is we also want to look at using the distributive property to simplify. We're going to be multiplying just like we have been. But remember, in the distributive property, what we do is we take the term outside and multiply it by each item inside. So here I'm going to take this 2x squared and multiply it by each item inside my parentheses. As I've done here, I've taken 2x squared times my x to the 4th plus my 2x squared times x to the 3rd. And then I go ahead and add my 5x to the 5th. Notice I did not multiply my 2x squared times my 5x to the 5th, and that's because the 5x to the 5th was not in parentheses. Now then, for here, I will multiply the coefficients, 2 times 1, and x squared times x to the 4th. Do the same thing here, 2 times 3, and x squared times x. I'll simplify as much as possible. This is 2. I add the exponents. 6, I'm going to add the exponents. And simplify even further. 2 plus 4 is 6. 2 plus 1 is 3. And this stays at 5. This would be my final answer. If there were any terms that had the same x to the same exponent, I could combine like terms. But this one does not have any like terms. Let's look at one example of finding the area of a rectangle. Here I have a rectangle and I want to find its area. The width is x squared and and the length is 2x cubed minus 1. Remember, area is length times width. So I'm going to say 2x cubed minus 1 times x squared. And I can do the distributive property just like I have been doing. I'm going to take my x squared and multiply it by each item inside the parentheses. I have 2x to the third times x squared minus 1 times x squared. And I end up with 2x to the fifth. I got the 5 by adding the 3 plus the 2 minus x squared. The thing to remember here is that when we're multiplying, we have exponents and they're the same base, such as an x and an x, we add their exponents. This is going to come in extremely handy when we're looking at other operations with polynomials and where we get into factoring, things of that nature. Go ahead and watch the other video that goes along with this section and then work on the homework. If you need other examples or help, let one of us know.